Hi, and welcome to Lipids. Now we are in our second macromolecule. We just finished up carbohydrates. We learned that there were storage and structural carbohydrates, which are our functional polysaccharides. And now we are on to the second macromolecule, and we are now entering the world of lipids. So lipids, this is going to be Roman numeral 5 in your notes. Lipids are something we call hydrophobic. When you hear the word phobic, phobias, arachnophobia, any kind of phobias out there, that means you have a fear of something. If you are hydrophobic, you actually fear water. So if you think of oil and water, when you mix them together, they don't actually mix. The oil stays by itself and actually gets together within itself to shun the water out. That's because fats are hydrophobic, lipids are hydrophobic, oil is hydrophobic, and they're all together in the same family. So let's talk about some lipids. And what you need to know is that lipids are a little bit different. I know we've been talking about polymers this whole entire time, how we link together many monomers to create long polymers. Lipids do a little bit different work, if you will. They don't necessarily form polymers because lipids are by definition hydrophobic. They actually just attract to each other. They don't have to react in order to be next to each other. So if you've ever had a big bowl of water, you put a drop of oil at one end of the water and another drop of oil at the other end of the water, over time, enough motion is happening, whether you see it or not, that those oil droplets are going to find each other because they hate water so much, they'd rather be together and get away from the water. And so oil is, so fats, oils, all that stuff that we're going to learn about right now are hydrophobic. So they don't necessarily form polymers, they just kind of attract to themselves. And so there's this phrase we use in chemistry, it's called like attracts like. And opposites do attract, but when we're talking about how something reacts with water or if it's hydrophilic, if it loves water, if it's hydrophilic, or if it's hydrophobic, they usually attract one to another. So let's talk about lipids. Lipids are a hydrophobic macromolecule that does not form polymers. However, they are large molecules because their hydrophobic nature allows them to link together. So lipids are large hydrophobic macromolecules that do not form polymers but link together due to their hydrophobicity. That's another word. That do not form polymers but I'm going to say link in quotes. They actually, I'm not even going to say link, I'm going to say attract to one another. Due to their hydrophobicity. And what we need to know is that there are 3 different types of lipids. So if you go back to what we learned about with carbohydrates, there were 4 kinds of polysaccharides, 4 major types of carbohydrates. We had starch, glycogen, cellulose, and chitin. So underneath every macromolecule we're going to study, you're going to see different types, and you're going to need to know things about every single type there are. So for lipids, we have 3 types of lipids. Here's what they are. So there are 3 types of lipids. The first one are the fats. So we have fats. Then we also have, after fats, we're going to cover our phospholipids, and then we're going to get into steroids. Fats, phospholipids, and steroids. 3 types: fats, phospholipids, and steroids. So the first thing we're going to do is focus on fats. So here we go. Big letter A is fats. Now this this language that we're going to use for the fats, this is something you've heard of if you've read enough nutritional labels and stuff like that. A lot of this language may be familiar to you, but now you're going to see the structure and how the structure relates to the function of that fat. So let's define what a fat truly is. Fats, what you need to know is that a fat molecule is one triglyceride. One triglyceride. You might have heard that term triglyceride before. If you've ever had a blood work done or studied your diet well enough, you could see how many triglycerides are in things. So they're literally counting how much fat is there. So a triglyceride, let's define that. A triglyceride is a molecule made of one glycerol, which is a 3-carbon molecule, and 3 fatty acid chains. We're going to look at all this stuff. So is a molecule composed of one glycerol and 3 fatty acid chains. So let's see what these things look like. So here's what a glycerol looks like. You have a 3-carbon chain, and coming off of every single carbon, you have a hydroxyl group. And the rest of it is covered with hydrogen. So this is glycerol. Now fatty acid chains. Fatty acid chains are very interesting. Fatty acid chains are long 16 to 18 hydrocarbon chains with a carboxylic acid at the end of a chain. So remember all these functional groups. We have our hydroxyl groups right here. A fatty acid chain would be doing the wrong thing. So you have your carboxylic acid there, and you have 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'll stop there. That is a fatty acid chain. So if you put 3 of these on one of these, you have yourself a triglyceride. So we're going to make a triglyceride right now. But I wanted you to see what they look like individually. So glycerol is a 3-carbon chain with hydroxyl groups off every single carbon, and a fatty acid chain, this could be anywhere from 16 to 18 carbons long. I've even seen some shorter, just depends on which fat you're talking about. But that's the typical range you'll see for fatty acid chains. So let's put together a triglyceride so you can see how one is made. So these are the components. These are the individual components. And I'm gonna get some space here. Because a reaction that we know and love is gonna come back into play again. All right, so go ahead and draw a glycerol. And we're going to add it to 3 fatty acid chains. So I'm going to put a fatty acid chain up here. And another one here. They don't have to be the same size. I'm just kind of making it uniform right now. And another one here. Okay, so here's my glycerol, here are my 3 fatty acid chains. What we need to do is attach these 3 fatty acid chains onto these 3 carbons. So this carbon needs to grab this fatty acid chain and link it to itself. This carbon is going to grab this one is going to grab this one. Whenever we're trying to link two things together, this is going to go back to what we learned about with how we link two monomers together. Remember what reaction helps link two things together? A dehydration reaction. So if you look at this, do you see where I can get water out of the equation again? If I have my hydroxyl group here and I have a hydroxyl group here, can I just bring these together to get some water? I most definitely can. So I'm going to have this OH group and this H group, and they're going to make water. I'm going to have this OH group and this OH grab that hydrogen and make water, this one, and boom. Then I'm going to link them all together. So now I'll show you what the final product looks like on the other side because we're adding all this together. Forgive me, I'm going to erase some of the chains here because I need space. So here's what they would look like. So once my reaction is complete, I'm going to have my glycerol, and I'll put all the H's here. All right, so now I'm going to have my fatty acid chains coming off every single carbon here. But as I bring these two together, this oxygen is going to be the link between my glycerol chain and my fatty acid chain. So here's what it's going to look like. I'm going to have my oxygen and my carbon with its double bond O and the fatty acid chain trailing behind it. Once again, oxygen, carbon, double bond oxygen, the fatty acid chain, and then once again, hence the name triglyceride. So I have 3, and I didn't bother counting my carbons. It could go as long as you need it to go. But every time, I want to see if you recognize this functional group right here. That is this right here, minus my oxygen. Do you remember what it's called, what functional group it's called when I have a C oxygen double bond oxygen, COO? It's an ester. In this case, it's linking together two chains. I'm getting my glycogen chain and my fatty acid chain, so this is called an ester linkage. And in this whole process of putting 3 fatty acid chains onto 1 glycerol chain, I made how many molecules of water? 3. So after all this is done, I'm also going to get plus 3 H2Os at the end of the day. So this structure right here, this whole structure right here, this big guy, this is called a triglyceride. And in between the glycerol and the fatty acid chain, you have ester linkages. So this portion right here, that is an ester linkage. And that is 1 molecule of fat. So triglyceride equals 1 fat. They're pretty large. And the reason it's actually good to eat some fat in your diet. You don't want to be completely fat-free. We use fat for energy. We use it for cushioning, for a whole bunch of stuff. It helps surround our body so we stay warm. So insulation, energy, and cushioning, that's a good thing to have, especially in an animal body like us. So that is how triglyceride is made. You have 3 dehydration reactions. To make 1 triglyceride. Okay, so now I'm going to stop right here because we're going to come back and talk about the 2 different kinds of fats that are out there in this world. You probably know about them. You got saturated and unsaturated fats. So come right back. We're going to talk about the 2 different kinds of fats.